the information in a slightly different form. So we're going to have the t value, the x value, and the y value. So if we have those things, if t is 0, what's the x value? If t is 0, what's the x value given what's up there? 0. And what's the y value?
0.
So what point are we at? We're at the point 0, 0. If t is 1, x suddenly becomes 1, and what does y become? What does y stay, actually? What is this? When t is 1, what is y? 0. So what point is it at? 1, 0. And then when you're at time 2, what do you end up at? 1, comma 1. So you're at 1, 1 now. And then when you're at 3, you're at 0, 1. So you're at 0, 1. And then at time equals 4, where are we? 0, comma 0, 0. So if you were to graph this, what would you end up with? So based on what you know, what would it look like? It starts at 0, 0, right? And then it goes to 1, 0. That's at time equals 1. And then what does it go to? 1, 0 at time equals... It's 1, 1. Thank you. It is 1, 1. You are absolutely right. 1, 1. It's time equals 2. And then it goes to, what, 0, 0, 1 right here? So 0, 1, that's time equals 3. And then what was time equals 4 again? Time equals 4. So what path does this actually make? It makes a square in this case. It makes a square. How else could we write it? We could write it as, there's one way. What about x equals, what's another way to write it? Negative 1 minus what? 3t. And y equals, sorry, not negative, yeah, 5, sorry, 5 plus what?
60.
Is that the same line? Is that the same line? If you plotted a bunch of t values, would it overlap exactly with this? Would particles be at a different place at a different time?
I think so.
At time equals 0, where is this thing?
Negative 1, 5.
Yes, is that right? At time equals negative 1, where would it be?
Negative 2.
To negative 1, right? Is this the exact same line as this in Cartesian form? Would these two describe the same road? Yes, they would. These would describe the same road. These describe a car traveling on the road. Are these the same cars traveling at the same time? No. This is a car traveling on one road at a certain way. It's on the same road at a certain way, right? Yes?
Where do we get the negative 3?
Do this one. X equals negative 1 what?
Minus 2.
And y is equal to?
5 plus 2.
5 plus 2t. Sorry, there should be a 2 right there, right? Like this. Are these all the same road, so to speak? Yes. The ratio is the same. Now, where the particle is at a given time is different for each of these, right? At time equals 0, where is this? 2, negative 1. At time equals 0, this is a 2, negative 1, right? At time equals 0, these are at the same spot, but they're not at the same place. So look at part B. It says the line segment from from 2, negative 1 to negative 1, 5. From and to means that you can imply time equals 0 and time equals 1. So of these 4 choices, which one would correlate to B? Which one of these 4 choices would correlate to B? Meaning time equals 0 is the first one right here, and time equals 1 is the second one right there. Which one would that correlate to? Yeah, would it correlate to 1, 2, 3, or 4? Which one?
I think 1 and
1. 4, 2, really? Does it work as well? You sure?
4. I think it works.
It does?
I
Plug in 1, does it work?
It doesn't work.
It doesn't work. If you plug in 1 into this, it turns into 1, comma 1, right? It doesn't end up, it doesn't go far enough. Like, this one's too slow, right? These two start in the wrong place, and this one's too slow. This one's just about right. Could I write a third one that's too fast? Can you give me the equation, x, give me the equation of 1, like 5, that would be too fast. It starts in the right place, it would be 2.
Minus 5t.
Minus what, 6t? And negative 1 plus what? 12t, right. This one would be too fast. Written terribly because I just dragged my pen across that. That would be too fast. So for B, we would want this one right there. It starts in the right place and it ends in the right place. Does that make, we pretty good with that? Time of t. 2 plus, yeah, we can write it differently, but 2 plus what? E to the t, which is another way of writing dx dt, correct? What is y prime of t? It's just 3, right? And that's dy dt, right? This asks, find the velocity vector and speed of the particle when t equals 1. So you guys wanted to do, for example, many of you went to speed first. If you wanted speed, speed is the what? Magnitude of the velocity vector. So many of you did write this nicely. You did 2 plus e to the t squared plus. So that's the speed at any time t, right? So what is the speed at time equals 1? Well, that's going to be the velocity, the magnitude of the velocity at time equals 1, which is going to be what? The square root of 2 plus e. Yeah, 2 plus e to the 1. I didn't put a parenthesis in there, sorry. Squared, right? Plus what?
9.
So that right there is the speed. You can just stop there, but you need the velocity vector at time t. What I want you to write for the velocity vector is like this. What's the dx dt going to be? 2 plus e to the t, comma, 3. This is how I want you to write this. How many people have seen vectors written like that before? Raise your hand. I'm sure you've seen vectors written like that. Key to this one, just to bottle this up, you need the slope. Because you have the point, all you need now is slope. Slope is equal to dy over what? Oh yeah, dy dx, absolutely. M is equal to dy dx. The key thing you need to remember is that's equal to dy dt over dx dt. So that's where the slope comes from. And this is at time 1. How do you know it's at time 1? Because when you plug in 1 into here, you get 1 cubed is 1, 1 times 2 is 2, which is this point. You were going to have to figure that out frequently. So when you do this, you end up with y minus 2 is equal to 2/3 times what? Was it x minus 1, like this? So Yana asked a really good point. What's the relationship between the 2/3, which is the slope of the tangent line, and the velocity of the particle at that point? Think of it this way. When you're traveling along, let's say you're traveling along on a roller coaster like this, and you're moving along. The roller coaster could be accelerating, it could have an engine in it. Let's say it's going really fast uphill. At this point, what's the tangent line? That would be the tangent line, right? Am I doing okay there? Is that a good? That's not bad, right? So if I asked you for the slope of the tangent line, this tangent line would be, I don't know, this could be about 2/3, right? This is about 2/3. Depending on how fast the cart is moving, the velocity could be really big or really small in that direction. So the tangent line is the direction you're moving in that instant. The velocity is how fast you're moving in that direction. So Josh over there originally had written, instead of 2/3, he wrote, I think he wrote root 13, right? Yeah. Because that's the velocity at time equals 1. Plug in 1, what do you get? 3/2. What is the magnitude of the vector 3/2? What's the magnitude of the vector 3/2? Square root of 9 plus 4 is square root of 13. But it's key that if you're doing a slope of, you need a line, you need a slope and a point. Excellent. Did you test this out? Well, let's see if it...
I mean, 2 is outside.
Well, hold on. So you can do it 2 ways. Oh, 2 is outside?
Yeah,
like 2 sine t? So something like this. X is equal to...
Sine t and over 2.
Over 2. So 1/2
Sine t.
sine t. So you could test this by plotting points. That's the first way you could test it at this point. You could say, okay, what are the intercepts for this one? What are the 4? When x is 0, what are the y-intercepts here?
1, -1.
Plus, it's 0, 1, and
0,
-1, right? Those are the 2 intercepts. And then what about the x-intercepts? 1/2, 0, and?
-1, 2.
So those are the intercepts, right? It's an ellipse with that shape. So let's just test to see if it goes through there. When sine is 0, what's sine of 0?
1, 0.
What's sine of 0?
0.
0. What's cosine of 0?
1.
1, right? So is 0, 1 a point here? It is. That's pretty cool. What's another trig value we could plug in?
Pi.
Pi. That's a good one. So what point do we have so far? We had 0, 1. That's when t is equal to 0. What about pi? What's sine of pi? Sine of pi, everybody? What's sine of pi?
1.
0. Sine of pi is what?
Wait, 0.
0. Sine of pi is 0. So this would be 0. What's cosine of pi? Okay, so we have t equals pi right here. Correct? What should we plug in now? Pi, t equals what? Pi over
2.
Pi over 2. What's sine of pi over 2?
1.
Sine of pi over 2 is 1. 1 times a half is a half, so that's the half right there, right? What's cosine of pi over 2? 0. So we have t equals pi right here. What can we plug in What time can we plug in next? What t value can we plug in next?
Negative pi over 2.
Or 3 pi over 2, right? Negative pi over, or 3 pi over 2, right? Let's do 3 pi over 2. So what do you end up with? You end up with that one, right? So is plotting points, I have a question. So does this make us believe we have the right answer?
Yeah.
Yes, but is 4 points enough? Like I've said, we need to find a specific graph that looks like this, right? And we've plotted, it goes through this point, this point, this point, and this point, right? Yay! Is that enough to prove that it goes through all the other points? No, it's really good evidence. It's really good evidence. Jana mentioned it. Is there a way, I think, where we can take this and turn it into that? Is there algebra that we could do to turn this into this? What do you think?
Times 2.
Hold on, you're saying the same thing. Jana, you said.
I said that we need to make sure when it's squared, it ends up.
We like that square. I taught you that squaring mechanism. So if you squared these, what do you end up with? X squared is equal to 1/4 sine squared t, and y squared is equal to? Now we can't just add them right now, but what can we turn this into? 4x is equal to what? Sine squared t, and, oh sorry, 4x squared, and y squared is equal to? Cosine squared t. So if we add these together, what do we end up with? 4x squared plus y squared is equal to? And we know that cosine squared t plus sine squared t is equal to? So do we have what we want? Yeah, look, we have this, and now we have exactly what we want. So we tested it with 4 points, and does it actually turn into the right one? It does. It does. Yes. Jana, your question.
So